for like episodic memory, things like that, that's very much you can just kind of dump the conversation into a context because it's relatively small amounts of information.
Right.
When you start getting into like short-term memory, you have to start doing some level of compaction or summarization of that data. Otherwise, you just end up with a context that gets really, really large and starts to have a lot of information that isn't necessarily kind of key and relevant. And then there's sort of the long-term memory aspect of it, which is I think really where graphs fit the best in a lot of cases, which is like the procedural memory or the personalization aspects of things where you're basically taking those previous interactions and then extracting out insights, extracting out, facts and in graph terms, things like that, that you want to keep moving forward.
Welcome to GraphGeeks in Discussion. I'm Amy Hodler. Today, I've asked Dave Bechberger to join us to talk about graphs as memory. Dave is an expert in RDF and property graphs. We've had many discussions on that, as well as graphs and AI.
Thanks. Thanks for having me.
Wonderful. So, Dave, for those that don't follow all of your posts, can you tell us what you've been working on lately and what you're excited about?
Sure. So yeah, I mean, for about the past 6 years or so, I've been working in software for 20 plus years and
Yeah.
graphs for like 15. And then for about the past 6 years or 5.5, 6 years, I've been on the Amazon Neptune team. And most recently, kind of what I've been working on there is the intersection of graphs, knowledge graphs with these upcoming generative AI technologies. So, like last year was a lot of work around how to make a graph rag applications, how to build and make those sorts of success. This year, it's been a lot of around MCP servers, things like that. And most recently, I've been focused a lot on working with agentic memory and kind of semantic data
Yes.
layer and how you can leverage graphs with generative AI.
And, for I've known, Dave for many years, and we're always keeping track of what's going on and, what research we're reading and what's interesting. And recently, this talk actually is, I asked Dave to come on because I've been, very interested in graph as memory and the different research there and just kind of understanding where that's going. But Dave, just recently there was a post on LinkedIn around graphs and memory, and a particular Anthropic's addition in Claude of memory into their chatbot, and I know it got a ton of feedback and comments and questions and disagreements, and just it was a really interesting conversation. And I thought it was like a good opportunity for us to just chat about like what is this excitement about, and why all of the energy and buzz around graph and memory right now.
I mean, I think that's it. I think it was very interesting that they came out with that because I think what it really does in a lot of ways is really show that they're seeing this fundamental need for memory inside of their
Mm.
systems. I mean, their memory is not specifically a graph, but I think it does kind of validate that this is a fundamental need of these applications, and that is to basically memory exists much like human memory, so you can remember
Mm.
things across interactions. Anytime you're working with an LLM call, it's a very atomic thing. It goes out, it comes back. It has no recollection of the last thing you asked it or the thing you asked before. That all kind of gets passed along as part of the context of this. And memory is really about making sure that the context that you're passing along gives those sort of relevant details to make it seem like that to make it seem like it knows what had happened before. I saw a great quote once that says like an agent without memory is like a goldfish. Everything is new every 3 seconds.
Yeah.
If you want to kind of pull that Ted Lasso, being a goldfish is good when you're a soccer player. It's not so good when you're doing your interactions with your agents or people are working on their shopping carts and things like that. That you really kind of want them to have that sort of continuity of information between things. So I was very excited by the kind of Anthropic
Mhm.
addition there. I thought it was like I said, it very much just validated that it was needed. And I think graphs are kind of the basic idea of context management has been around as long as LLMs have been. But the idea of being able to use graphs to really optimize that, I think, is a bit of kind of the new aspect of that.
Mhm.
Certainly come a lot. It's become more and more prevalent as agents are becoming more and more prevalent.
Mhm. So why, and it is all the buzz, especially in the graph space and the people that we talk to, but why do you think graphs apply to context memory versus, another type of data format or data model?
I think a lot of it comes down to it especially when it really sort of depends on the type of memory you're talking about. There's, at least
Mhm.
when I think about it, there's lots of different types of memory out there. Is like
Yeah.
if I had to kind of categorize them into high levels, I would kind of call them episodic memory, short-term memory, and
Okay.
then long-term memory. So episodic memory is very much transactional sort of based. Here is the exact conversation you just said. Put it in there, something like that. Short-term memory is going to be a bit of a longer term. Probably think about it in terms of like one session of interactions with some sort of chatbot, things like that. And then long-term memory is going to be about being able to remember patterns, trends, things like that, around preferences, things like that, that you're going to use across multiple different interactions.
Mhm.
Like you said, this idea of being able to have these sorts of memories really kind of mirrors our own internal human brain, which is where I kind of think they go with the memory, the sort of memory
Yeah.
terminology. But, for like episodic memory, things like that, that's very much you can just kind of dump the conversation into a context because it's relatively small amounts of information.
Yeah.
When you start getting into like short-term memory, you have to start doing some level of compaction or summarization of that data. Otherwise, you just end up with a context that gets really, really large and starts to have a lot of information that isn't necessarily kind of key and relevant. And then there's sort of the long-term memory aspect of it, which is I think really where graphs fit the best in a lot of cases, which is like the procedural memory or the personalization aspects of things, where you're basically taking those previous interactions and then extracting out insights, extracting out facts and in graph terms, things like that, that you want to keep moving forward. If for example, if I
Right.
was going to book a plane flight, something like that, my episodic memory might be, okay, book me this specific flight. My short-term memory might know that I'm flying from Anchorage to Seattle, but my long-term memory may know that I prefer aisle seats over window
Right.
seats, and I prefer, you know, the kosher meal or something like that. Those sorts of long-term things that aren't going to change that rapidly.
Mm. It's funny, to think about it in a human, well, maybe not funny, in a human sense as well, because if I think about how, humans remember things, and, in the short term, we do remember, like, exactly what happened, and then, you slowly abstract out concepts, for longer term storage, and that's also kind of how we learn. We don't learn or how we learn a rule or heuristic for something. It's not that somebody actually taught me this heuristic or this rule. It's just I did it enough times to where it, reinforced, if you will, that this was the concept or the rule that I should be following for something. So it makes sense that being able to abstract that out, you would want to do that for more efficient long term memory, but also more generalization as well. Um,
Well, I think your
yeah.
your example, I mean, what you just said there is really kind of right on. Nobody necessarily taught you all of the rules of life.
Yeah.
No one necessarily that taught you that, okay, you put a pot on a stove, the stove, that the stove is hot, the pot that's been sitting there. No one probably taught you that the pot is also hot, but you were able, because there was those two things, you were able had those two
Yeah.
pieces of information, you were able to connect together and make some inferences or reason over that to basically say, the pot was just on the stove, it's probably hot.
Yeah. Well, and to take that one step further, that any pot on any stove that's on is probably hot, and even a pan too. It doesn't have to be a pot. Like if you,
Yeah.
yeah, whatever it might be. And then I would say from a graph standpoint, for me, the natural fit with graphs is again you're compressing into more generalized formats, and graphs also allow you to abstract concepts as well. And so, that kind of all fits, with, like, why graphs for memory, yeah.
Yeah. Well, and I think that's actually a really, really great point you had there about basically the compressive nature of graph data
Right.
compared to something like, Actually, it was the ZEP paper, the paper that they published.
Mhm,
ZEP is they make a memory system.
mhm,
So inside that paper, there was one table that stuck out. Like most things, they're obviously talking about how good graph memory is, but there was one table that really stuck out to me. Forget, I think it's like table 4.3.2, something like that. But what really stuck out to me was they compared essentially graph memory,
mhm,
dumping graph memory into the context versus dumping the full conversation history into the
mhm,
context.
mhm,
And the scores were, they weren't exactly the same, but we could just pretty much think of them almost as a wash between the two.
mhm,
But the part that really stuck out to me was because you're using a because the graph the data it was providing from the graph
mhm,
was kind of a summarized, compressed version of that information. Um, that it took, what was it, 10 times less. The time it took to actually get the answer from the LLM was 10 times less, and it used 70 times fewer tokens. So from a scalability perspective, that's huge, not only in latency and
mhm,
cost to basically, if you have 70x less cost and and you can run things 10 times faster, right there alone is a very good reason to look at
mhm,
using a graph for those sort of long-term
mhm.
memories.
Since we've wandered into the paper space, was one of the things I wanted to talk to you about is what are you reading? What should people read to get up and going? And for the listeners, I will put links in the description for you. But yeah, tell me what we should all be reading.
I mean, there's a lot of good papers out there about kind of graphs and memory. The couple that I've been reading most recently, other than the ones that were provided by the several of the different memory vendors, which obviously are going to have some some skew to them. um, I was reading there was a paper on MemGPT, which was a very interesting kind of system around how to build and optimize memory for LLM based applications, which I thought was kind of a slightly different way to look at the same kind of problem. And I think is actually even, I think that's a lot of what like even the Anthropic memory system was kind of built on, with some of the ideas out of that sort of
Mhm.
paper.
And so that paper, not necessarily about graphs, but about just optimizing for LLMs. How
Yeah.
did graphs come up during that paper or yeah.
I don't think they explicitly talked about graphs in that paper, if
Mhm,
I remember. I'd have to go back and read it to be sure. But I mean, at least I mean, the way I kind of think about the problem is really, the problem you're trying to solve is giving agents that context. And
mhm,
then it kind of comes down to, okay, now that I've decided that this is the problem I want, what is the right technology I want to be able to use to store that information? Is it a graph? Is it just a key value store? Is it something else? And that's going to be a bit dependent on the application that you're looking for. Um, you know, most any agent framework you're working
mhm,
with already has some level of kind of memory, or often called context management, inside of it. So they're already getting some of that like episodic memory in there. It's really, depending on your application. If your application doesn't need much more than that, then that may be sufficient. But, other applications where you have, users that run longer sessions, longer sets of interactions, are going to need that sort of short-term memory.
mhm,
And something where you have those sorts of long-term interactions where you have users that are using it every day or at a frequent pace is where you
mhm,
need to look at some of those long-term memory operations. And then once you've kind of decided which type of memory you want, now it's a
mhm,
matter of, okay, how do I go and optimize? What am I looking to optimize for? Am I
mhm,
looking to optimize for ease of building, or am I looking to optimize for kind of performance and scalability in the long term? And
mhm.
that's where I think you start to get into the question of, should I store this memory as a graph? Should I store this memory as a key value store?
If I'm remembering the paper correctly, and that's I was just looking for it's somewhere on my desk here,
Yeah.
that it was my biggest takeaway from that was you can use classic operating system, memory concepts to look at, modeling that, using that model, to help looking at, how to model memory for LLMs. What did you key takeaway on that one before we maybe move to another? That felt like a good primer to me.
Yeah,
Yeah.
that's kind of what I was looking at. Is I think it's a very good primer. I think my takeaway is kind of very similar. I think it's like with a lot of Gen AI concepts, like everything old is new again. We don't have to necessarily reinvent the wheel. We just have to look at the art that exists out there and figure out how we can
Yep.
apply it to what we're
Yeah.
doing.
Yeah, absolutely. Okay. So that's the starter. What would next paper be that we should look at?
I mean, the next paper I would probably this is might be where I start to look at some of the specific vendor papers, because I think
Mhm,
it's interesting to look at how
mhm,
the, you know, between kind of the couple of the key vendors, someone like a Mem0, like a Zep, like a Cogni out there, how they are
mhm,
solving the same problem, but each taking a slightly different tact or tilt on exactly how to do it. Like Mem0 has very much a tilt towards really being able to kind of hyper personalize those individual graphs that you're working with, and they do this through building out kind of a very domain specific knowledge graph model, if you want to
mhm,
kind of call it.
mhm,
Something like Cogni has really actually leveraged a lot. They're kind of more higher level sorts of memories, kind of shared across many people, and they kind of really go with almost a lexical graph model with some fact extraction out of it. And then you have like Zep in their graffiti, which also is a lexical model, but it's got some community in it, and it has a very temporal aspect to it, which I think is an interesting aspect to memory as well, is that things can be very temporally appropriate or not appropriate based on what
mhm.
what it was. You know, Great example of that would be something like if it was a personal shopper sort of application. Well, it might know that I like these sorts of shorts, but it's the middle of winter. Like, probably not the best to recommend shorts in the middle of winter sort of idea.
All right. So let's back up on some of these. The Mem0 paper, I believe, if people are looking for it, and I'll do a link, but it's Mem0 something temporal graphs. If you have it in front in front of
I
you,
don't have it. I don't have
um,
it in front of me right now. Yeah,
yeah.
it's.
I'll include a link, but that one was, that one I thought that was I think I read that right after the, Mem GPT, paper. That one I thought, was a really I thought they had a really nice architecture as well as far as, the conceptually things you could use for, um, really short context, mid or short-term memory, and then, long-term memory as well. So I thought that one was interesting, and if I remember correctly from that one, they were looking at, accuracy, like, they were really focused on, like, super, more accurate. Yeah.
I mean, I don't. I'm always a little skeptical of accuracy because it's a very, in some ways, it's kind of a subjective sort of thing. What is a better answer? It's always a tough one to give. I mean, I know
Yeah.
you could measure, the facts that are relevant, but it's sort of, uh, in the end, does it matter? Does it give me a better answer? I think is really the key metric that we need, that we should focus on as we're building these out.
Yeah. And that kinda contrasted really strongly for me with the Zepp paper, which again, I'll link to, in that they seemed more focused on, I don't wanna say practicality, but maybe efficiency. I mean, still accuracy, but it also seemed to maybe more focus on the context, window as opposed to maybe, like, long-term memory. What did was that your takeaway, or did I am I reading them back to back maybe gave me more contrast and
I mean,
perhaps
I
the
think that's an interesting contrast. I think what I got more from the Zep paper was they're very focused on the temporal nature of
yeah,
the
yeah.
data, more than just the temporal nature and deeper retrieval. It is sort of what I kind of got
Oh.
out of a lot of that. And like I said, that's why I think it's interesting. I think the whole space is relatively new, so it's hard to say which approach is going to be
Mhm,
best, or what I suspect is probably more likely is different ones are going to work better in different scenarios. Um,
mhm,
And I think it's just really interesting how there was a very disparate approaches,
mhm,
both leveraging a graph, but leveraging very different models and styles of graph.
mhm. And the Cogni paper I haven't read, at all, so that's on my to read list. What were your key takeaways from that paper?
I think the at least the part I found most interesting there was really how they have taken their system, which was sort of initially built for more graph rag type interactions and
Mhm,
applications, and how it kind of naturally also morphed to be able to do agentic memory sort of at needs. The kind of overlap between the two was
mhm,
was was bigger than I was kind of initially expecting it to be. To be honest, when I kind of thought about it, I was like, oh, these probably need different models, different use cases, and really,
yeah,
It kind of comes down to it's like I said, it's still new, but I think it seems like the models you can use to answer the questions are very similar, but the workload you're putting on them is really where it differs.
Mm. Do you, if you were to characterize, or how would you characterize the different approaches if we had to put them in buckets? And I realize there's always overlap, but you mentioned with the ZEP approach and other, so there's probably a bucket of more temporal approaches, and maybe there's a bucket of and this might be, tell me if this is incorrect, but maybe Cogni falls into a more of a rag type model approach, and maybe somebody else fall, does the mem zero, what's their approach, like, are there natural categories or buckets we can start putting things in?
Yeah, I mean, I would say that that's pretty pretty accurate. I would probably say if I was going to talk about like Mem Zero, a lot of it comes down to it. What it's building is what I would say most people would think of as kind of a domain knowledge graph. Kind of if you asked a person a knowledge graph looks like, it's probably the closest there, where you have you know entities that are connected to other entities
Mhm,
through a wide ranging set of relationships, things of that
mhm,
nature. I would say the like Cogni is very much it's leveraging the same lexical kind of graph pattern that you tend to see for graph rag sort of use cases. And
yeah.
Zep really kind of falls into, I think, the temporally focused or temporally optimized, maybe is a better way to do it. Graph type approach.
So would we, so I'm here, I'm driving towards some category names. So I've got a well, we've got like domain knowledge graph, a lexical graph, and a temporally optimized lexical graph as three potential buckets.
Yeah.
Are there which other people could have, could write their own paper or do their own experiment in, with these different approaches. Are there other approaches that either you've read about or that seem logical to you that we haven't seen papers on?
I mean, I haven't seen specific papers that I can think of on it, but I think there's probably another category in there of like a very procedural type of graph, where it's really dealing with like where it's dealing with memory that really spans many people, where it's not like necessarily going to be specific to you, but sort of more domain company specific of we do X before Y, we do Y before Z. In this sort of scenario, you can't do that sort of thing. Um, those sorts of I don't want to call it rule based because it's a little more than just like rule based, but like
Uh-huh. Uh-huh.
some of those rules and things around it,
Mm.
terminology, things of that nature.
I, I like that. I like the term procedural. I sometimes have called that a computational graph, but I think that's also gets confused with other capabilities. Where you're actually running things as a DAG, through a DAG and things like that. So, but procedural graph is a nice term for that. I'm going with it. I'm going to steal it. So,
Yeah, well, I mean, that's the problem with this space right now is there's so many terms that are so overloaded. It's
yeah.
Is it a knowledge graph or is it a graph? Is it a schema or an ontology? All of those challenges.
Dave, one of the things that I have noticed, and I saw this a lot in the post that I mentioned, people are really excited about ontologies and getting their data into a graphy format. And I'm wondering about this presumption that by just getting your regular enterprise data in a graph format, that somehow you'll automatically be ready for not just better AI, but almost having like graph memory for your AI. And I see those things as like two different threads, both valuable, but they're probably different efforts and maybe different teams and things like that. But what's your view on that?
I mean, I think in general, I think it's pretty well established at this point that having some level of schema, ontology, domain knowledge, and applying that into your LLM does provide better results back to the end user. I mean, it's never going to completely get rid of hallucinations or anything like that, but it will provide better, it has been kind of, I think, pretty much settled at this point that it does provide better. The exactly how much better, I think, is probably up for debate still. But I don't, I think that part is well shown. I think just assuming because you have that, making the leap to the fact that that is what you also need for agent memory is, I think, still to be kind of proven or shown. I think in theory and in certain scenarios, that's probably does make a ton of sense that having that sort of those sorts of procedural pieces of information, those sorts of high level domain concepts well known to
Mm,
your LLM will provide better answers. But I would say it's probably definitely not going to be universal, because even within a single organization, there's going to be different ways people work with things. There's different contexts around exactly what they mean when they're talking about specific things. Um, and having that contextual awareness, I suspect, is going to be a very important part. I know that you can do that with a lot of ontologies that, people that build like formal ontology and things like that do handle that. But that's also a pretty large amount of work for someone to build, maintain, and then evolve as the domain evolves. So I think there is a pretty significant chunk of work required to build something that would potentially handle all of that. And that's not something I know whether, I'm not sure if that's something that most companies are going to be willing to invest that much in on the hope that it works.
mm. That makes sense, and it kinda goes to something you said earlier about, procedural graph is one of the potential models. It definitely feels like that might be one that is, more multifunctional, in my mind, because that usually spans different purposes. It also says if you're thinking about graphs, if you have a graph use case for using the graph, connected data, siloed information, famously fraud, all of those wonderful use cases where you're connecting the dots. That makes sense in and of itself, but if you're doing that, just think about how you can use it in other places as well, such as, potentially in the future for memory. Um, that begs another question. If people are tantalized by this concept of graph as memory, should they wait and see for the dust to settle? Should they start exploring? Should they get up?
I
What should
mean,
they do if they're interested?
I think much like everything else kind of in the Gen AI space, this is areas kind of rapidly evolving as we're kind of even talking here today. There's probably But if I had to guess, there's probably a new paper published out on this today, even though I have no idea. There'll be one tomorrow. Like
Yeah.
it's one of those sorts of
Yeah,
areas
yeah.
that has a tremendous amount of velocity as far as things are going. I think the real key that I would say is that, do you have a problem where you think memory might be a good use case for it? And if so, then start to look at, okay, what sort of memory do I need? Do I really need to have a short-term or long-term memory? Do I need some level of procedural memory, things like that? And then use that to kind of guide whether, start from the problem and work towards the solution. Don't start from a solution and work towards the problem. um I would is I think that the general advice I would give there. I mean, I think one other, just kind of going back to what we talked about last, in the last question. I think one other interesting area to think about is not even just, from a procedural graph perspective, that your procedural graph it may be a type of memory. It may also be a type of guidance for agents to know where to even go to find different data sources. Because, the classic knowledge graph paradigm is I have data in many different silos and I need to be able to I want to connect them all together. Well, that same idea is important to agents where they need to be able to know that sales data lives over here and customer data lives over here, and this column here in this table is related to this column here in this table, and those sorts of uh a procedural sort of idea can be a type of memory that could be leveraged by agents that is stored in a graph, because it kind of does fit into a graph. It is a graph. Whether you store it in a graph is a different question. Is the second part.
Yeah. So thinking about getting started, we're gonna provide some papers. Would love to hear from other people who have their favorite papers. I haven't seen a lot of graph memory talks at events yet. Um, and that's something that I would love to see. So if you are, hosting an event, doing, training, please help incorporate, more, memory, because I do feel like that's an area that we're going to see some innovation in now going forward. Are there other things that you would recommend people get started with beyond, the papers and maybe just looking for material? Are there work groups or anything like that that you're participating in?
I mean, I would say from as far as getting started, the first place I would look is go look at some of the common frameworks out there. Don't necessarily try to reinvent the wheel. At least figure out what they did and where it works and where it doesn't work. It certainly will. These companies have put a lot of time and effort into building these. They've learned lessons that you don't want to have to learn the hard way. I mean, as far as specific kind of work groups, I am not super familiar with any kind of memory focused work groups out there specifically. There's definitely there's a lot of online blogs, chatter, things like that around it. But I'm gonna plug GraphGeeks here as a good place to go talk to people if you're actually
Yay.
interested in using graphs. Using graphs for this sort of thing. There's a lots of very good advice that kind of comes in there. Not necessarily saying A is, to use A technology or B technology, but kind of what are the, it's like everything else. There's trade-offs for going each direction. So really understanding those and what works best for your scenario.
Yeah, absolutely. Well, thank you for plugging GraphGeeks. Always appreciate that. It is a topic that I know many folks in the channel, the Discord channel in the community are really interested in. I feel like there is a ton of potential, for, memory innovation in general, but also, as you said, graphs are a natural way to store, at least it feels like a natural way to store memory at different levels and different levels of abstraction, which has a lot of benefit. But I like you, I don't know where we're going. I don't know where we'll end up. So yeah, I'm terribly interested to hear from community as well if there are certain um, directions, panels, things like that that the group can maintain. Try to keep up to date. That would be awesome. So
I would
yeah,
say the other
go.
thing is just if you try out graph memory or memory in general, I'd love to hear your feedback on what works and what doesn't work for you. Because like I said, I think it's such a new. I mean, a year ago, agents weren't the big thing, and now they are, and this is sort of a follow-on from that. So it's even more novel than that. So I think there's a lot of discovery of the
Yeah,
challenges that is.
absolutely. All right. So to wrap up on this topic, what are you, if we think about memory in general, or maybe let's even abstract it. Let's like AI and agents and memory. What are you most excited about in the next 6 months, or what are you hoping to see people push into?
I think the area where I really like to see us start as is just a kind of a whole cohort of people to start pushing into is more. What does it, we've kind of worked through some of these, agent frameworks, things like that. What does it really, what sort of challenges are we really going to start to run into when we start trying to do them at scale, at production levels with real data that isn't necessarily curated, that you know, all data is messy. How can we actually make these work very well for those sorts of things? And how can we do this in such a way that does not give people the feeling that they're working with an AI agent and that it doesn't, we've all had those experiences where it just kind of something doesn't quite feel right. How do we get away from those sorts of experiences? Is this the way we can help with that?
I had a conversation that I think you'll appreciate with a group the other day about planning for problems. Just in the world of building bridges and energy plants and things of that nature, you think about resiliency, you think about redundancies, but you actually plan for things to go wrong, and you try to figure out like, okay, I can't have a completely robust but fragile environment. I can have a robust environment, but I have to actually plan for things to go wrong, as opposed to just preventing them from going wrong. And I look forward to that level of thought of hubris. Maybe it's a level of hubris in our planning that, we will never build the perfect system. We must, be ready for things to go wrong.
I don't know if it's hubris or it's maturity, just kind of maturity of a technology that all of a sudden you realize that no matter what you do, it's never going to be perfect.
Yeah. Yeah. I don't know. I think in personal life, it feels like both to me.
A little from
Anyhow,
column A, a little from column B.
yeah, we'll take a little mix. It's neurosymbolic, right? All right. That was really dorky. But we'll probably leave it there for now. Dave, it was so wonderful to chit chat a little bit on this topic. Such a huge topic, and I'd like to revisit it at some point when we're a little deeper in the memory space and ready to talk about like maybe findings and practical applications and things like that.
No, sounds great. I'd love to.
All right. Thank you again, Dave. Thanks everybody for listening.
Thank you.